Hi everyone, in this video we will try to solve a interesting and simple question which is related to electrostatics. The question is like this: if two charges are placed at a distance of r, so let us say these two are the two charges which are placed at a distance of r. Now, where should we need to keep a third charge if these two charges q1 and q2 are like charges? And I want to know where I need to keep a third charge q, where I need to keep a third charge q such that the force on this third charge is 0. Let us assume the distance of the third charge from the first charge is x. So the remaining distance will be r minus x. So this is the remaining distance. So r minus x is the distance between q2 and q, whereas x is the distance between q1 and q. Now the idea is to prove that idea is to show that the force on charge q due to q1 as well as due to q2, these two forces are of equal magnitude and in opposite direction. If these two forces are of equal in magnitude and in opposite direction, then only the force on the third charge will be 0. Now, let me write the expression for the first force. So, let us write the expression for the first force, that is F1. So, what is the direction of F1? It is in this direction because this is the force exerted by the charge Q1 on Q. Okay, now what is that force? F1 is equal to the product of charges Q1 and Q divided by 4 pi epsilon naught x square. So this is the force exerted by Q1 on Q. What is the next force? The next force is the force exerted by Q2 on Q. It is actually in this direction. So the expression for that force is F2 is equal to Q2 into Q by 4 pi epsilon naught. Now the distance between Q2 and Q is R minus X. Therefore, in the denominator here, you will get R minus X whole square. Now we got the mathematical expressions of two forces. If these two forces are of equal magnitude, then the net force will be equal to 0. Therefore, our idea is to make them as equal. If you make them as equal, the equation becomes, first I am writing the F2 Q2 Q by 4 pi epsilon naught into R minus X whole square. It must be equal to F1. So what is F1? It is q1 into q by 4 pi epsilon naught x square. Cancelling the corresponding terms here. So I'm cancelling the corresponding terms. So q and q here cancels out. 4 pi epsilon naught, 4 pi epsilon naught cancels out. Therefore, the equation becomes now q1 by x square is equal to q2 by r minus x whole square. Okay, sending the distance terms to one side and the charges to other side, this equation is converted like this: r minus x whole square by x square is equal to q2 by q1. Now in order to get x value, what I am trying to do is I am just applying the square root on both sides. Okay, when you apply the square root on both sides, the term in the LHS becomes r minus x, because square and the root gets cancelled out, by x is equal to under root q2 by q1. Now applying the denominator x to both the terms r and x, you will obtain the equation as follows, which is r by x minus x by x is 1. So I am writing just x by x is equal to under root q2 by q1. So x by x is 1. When you send it to RHS side, it becomes r by x is equal to under root q2 by q1 plus 1. Actually, I want to find x because what is x? If you see the diagram again, x is the x is the distance of the third charge from the first charge. So I want to find x. Okay. So in order to find the x from the equation, what we can do, we can send this entire denominator, this entire expression to LHS side, so that you will get x value as r by under root q2 by q1 plus 1. Okay, so this is the expression for the distance from the first charge, such that at that position, if you place the third charge, the net force is 0. Okay, this is the case with the charges of, if the charges are like charges. Now, before concluding this video, I will encourage you to do the same analysis if both charges are unlike charges, and you wonder that you get means you will get the same expression for x, except here you will get a minus. Here you will get a minus sign for x if both charges are unlike charges. Okay, so I am encouraging you to do this on your own. So if you really like this video, please hit a like button and subscribe to our channel.